Hi friends, in this video I am going to explain what you mean by array uniqueness problem and how to write the algorithm for this problem, and after writing the algorithm, so we'll do analysis. So let us take this example. This array is having 5 elements. In this all the elements are unique. That means all the elements are different from each other. That means all the elements are distinct. If an array having all the elements are distinct or unique, then we can say that array is an unique. Now let us take this example. In this example, the element 4 is repeated. So that means there are 2 elements are same. Here the same elements are there. So now in this case, we cannot say our array is unique because it is having some repeated elements. So if an array is having a repeated elements or duplicate elements, we will say array is not unique. Suppose if all the elements of an array are unique, we will say the array is unique. Now let us see how to find the array is unique or not. Okay. So now we'll start the process. Now what I did, I selected the first item and I start comparing the first item with all the remaining elements. First I compared this item a of 0, that is 9, with a of 1. These two are not equal. So then I compared with this item with the next item. Again these two elements are not equal. Again I compared this element with the next element, that is 9 and 2. Again these two are not equal. Again I am comparing these two elements. Again these two are not equal. So now this is during the first pass or round 1. So during the pass 1 or round 1 or cycle 1, whatever you can call. So what we find out is only the first element is unique. There is no duplicate element like the first unit. That means first element is unique. That's it. Okay. We don't know remaining things. So now we need to check the remaining element also in the same way. Now what I will do, now I will select the second item. Now I select the second item, and again I start comparing this selected item with the remaining elements. Now here we no need to compare this element again with this element because already we covered here. We compared with 9 with 7. 9 with 7 or 7 with 10 and both are same. So already I compared these two elements. So no need to compare. So the remaining element from the next element of the selected items will start. So I will compare these two. Again these two numbers are not equal. Again I will compare these two not equal. I'll compare these two not equal. So after the pass 2 or round 2, we'll came to know that second element is also unique. There is no duplicate element in the remaining elements like this element. This is what the conclusion after pass 2. Similarly, now what we will do, now I will select the third element. So then I will start comparing this element with the remaining elements. So 4 with 2, again these two are not equal, again these two are not equal. So after pass 3, what we observed is there is no duplicate element like this third element. So third element is also unique. So after 3 passes, we'll came to know that first, second, third. The first 3 elements are unique. So in each pass, we'll find out whether one element is unique or not. Okay. So now, similarly, now what we have to do? We have to check the next element. I selected the next element and then I compared this element with its next element. Again, these two are not equal. So this is the end of pass 4. So there is no other element. So this is the last element. So now after pass 4, so now we came to know that fourth element is also unique. There is no duplicate element like this in the remaining elements. So now next step, no need to set, because if I select this item also, no elements to compare. So I will stop here only. Okay. So now after 4 passes, we came to know that all the elements are unique. So there is no duplicate element like this, no duplicate element like this, no duplicate element like this, no duplicate element like this. So now we came to the conclusion that the given array is unique. So now for this, now let us write the algorithm. So I have taken the name array underscore uniqueness, and parameter to be passed to this algorithm is the given array to be checked whether it is an unique or not. So I taken a of 0 to n minus 1. See here I took an array which is having 5 elements. So starting index is starting from 0 I have taken, and it is ending at the 4. So 5 elements, the last index is 4. Similarly for 6 elements, the last index is 5. Similarly for 10 elements, the last index is 9. So last in general, if it is having n number of elements, the last index is n minus 1. So I have taken a of 0 to n minus 1. Now here what we did first here in this procedure, what we did first, so first I selected. Then I selected. So I selected this one. So for selecting, so I will take the index I. Here I selected this one. Next in this pass I selected this item. So this is I. So in this pass I selected this item. So this is I. And here I selected this one. So here I indicates the index position. That means whatever the element is there in this position that I have selected. Whatever the element is there in this position 1 I have selected. Whatever the element is there in this position that I have selected. So I have selected I. So now this I, that means the process of selecting one item in each pass, whether I have repeated or not. Yes, we have repeated. So whenever we did some repetition, we have to use some loops. So here we know exactly from where started selecting and where we ended. So where we started selecting from the position 0, and where we ended exactly at what? Last but one position. Okay, last but one position. So last position is n minus 1. Last but one position is what? N minus 2. So we have selected the item from the 0th position to this one. Till that we have repeated. So I am using what? For loop. So for I is equal to 0. I started from selecting here. And I selected up to what? Last but one position. So it is n minus 2. Do what? After selecting what we did, after selecting, I compared the selected item with the next element. Okay. And I started comparing with this one. So I will take for selecting J, so for comparisons. So J, so next after that, I compared this element. After that, I compared with this element. I compared with this position element. So here I started J from the next position of I, and I compared till the last position. Similarly here what I did, so here after selecting this position, so I started comparing with next element. So this here I starting J, so then I started comparing with this position element like this one. So now here also I started J from the next to I position until the last position. Similarly here also I started comparing. Okay, so now comparison operations also we repeated. So here we repeated comparison operation from where we started. Again we know exactly from where we started comparing and where we ended. We start, if you observe in all the 4 cycles, we started comparing the element next to the I position until the last element. So again I will take one more for loop, that is for J. I started from where? Next to the I position, next to the I position, next to the I position, next to the I position. So I will write next to the I position means I plus 1. To what I did, up to where I compared, up to the last element, up to the last element, up to the last element, up to the last element. So last element position is what? N minus 1. So now what we compared? I compared what? If A of I is equal to A of J, that we checked. If this is true, what happens? Suppose if in this example, no elements are equal. Suppose at any point of time, any 2 elements are equal, then what happens? That array is not unique. So I have to return what? False, saying that, indicating that array is not unique. So that's it, the algorithm. So we need to check for all the elements. Sorry, this is int for. So again, this is int for. So finally, after coming out, checking with all the elements, then we have to say what? Return true, indicating the array is unique. So this is the end of the algorithm. So hope you people are understood this algorithm. Now let us trace this algorithm. So initially I is equal to 0 I selected. So let us take I is equal to 0 I selected. That means I selected this one, I is equal to 0. So then 0 less than or equal to 3, because n value is 5. Here n value what we taken, n is equal to 5. So 5 minus 3, 2. So 0 less than or equal to 3, true, comes inside. Now j is equal to I plus 1. I value is 0. Now j I am pointing to here. So next j is less than or equal to 4, true, comes inside. A of I is equal to A of j. That means now I am comparing this element with this element. These two elements are equal. Condition false, comes out of the if block. Go to the next iteration of the jth for loop. Now j goes to the position. Next j this position. So now again, this is condition true, comes inside. Now I am checking what this with this one. So A of I is equal to A of j. Again condition false, comes out of the if block. Go to the next iteration of the part of the j for loop. Now j becomes what? J becomes 3. So 3 less than or equal to 4, true, comes inside. Now I am checking what? A of I is compared with A of j. Now again these two elements 9 and 4 not equal. So not equal, condition becomes false, comes out of the if block. Go to the next part of the next iteration part of the jth for loop. Now j incremented to 4. Now j is 4. Condition here, j is less than or equal to 4, n minus 1, 5 minus 1, 4 is equal. Again condition is true, comes inside. Now I am checking this a of I with the a of jth element. Now these two elements again not equal. Again this condition false, comes out of the if block. Goes to next iteration of the jth for loop. Now j becomes what? 5. So now at that time 5 less than or equal to 4, condition false, comes out of this for loop. When condition comes out of this for loop, now it goes to the next iteration, that is next becomes I becomes 1. Now what I do, I becomes 1, that means I am selecting this item, so I becomes 1. So next I is less than or equal to 3, condition true, comes inside. Now j is equal to I plus 1. Now I right now is what? 1. So I plus 1 means 2. Now j starts from here. So 2, j is 2 here, 2 position, 2 less than or equal to 4, true, comes inside. A of I is equal to A of j. That means now I am comparing what? This with this element I am comparing. These two elements are equal? No. Again the condition becomes false, comes out of the if block, goes next iteration of the jth for loop. Now j becomes what? 3. So again 3 less than or equal to 4, true, comes inside. A of I is equal to A of j. Now I am checking what? This element with this element. 7 and 4 is equal? No. Again the condition false, comes out of the if block, goes to next iteration of the jth for loop. Now j becomes what? J becomes 4. Now again comes to the condition 4 less than or equal to 4, true, comes inside. Now I am checking A of I. That means now I am comparing this element with this element. These two elements are equal. Again condition false, comes out of the if block, goes to next iteration of the jth for loop. Now j becomes 5. So now j 5 less than or equal to 4, condition false, comes out of this for loop. Now again control goes to the next iteration of the ith for loop. So when I becomes 3, that means now I am selecting the next iteration, this one, 4 I am selecting. Now what I am doing next, I value is what? I value is 2. So 2 less than or equal to 3, true, comes inside. Now j is equal to I plus 1. I is 2, j becomes 3 now. So 3 less than or equal to 4, true, comes inside. A of I is equal to A of j. Now I am comparing these two. Now these two are what? Equal. So now if the condition is true, now in this case, whenever this condition true, control comes inside the if block, return false. Okay, return false. That means this array is not unique because it is having equal element. So this is how this algorithm works. Hope you people understood by tracing. So you can take this example also for true case. Okay, true case. Now we will do analysis of this algorithm. So what is the first step in the analysis? We need to decide the problem size. What is the problem size? So in how many elements are there in the given array, so that we need to check that. So for here, problem size is n, that is the number of elements we need to check. Okay, whether they are in duplicate are there or not. So second step is what? To identify the basic operation. Here, which is the basic operation? Actually, what operation we did here? So we compared. So in each and every pass we compared. So comparison operation is the basic operation. Okay, comparison operation is the basic operation. That is A of I is equal to A of j. What is the third step? Now we need to decide whether we need to find all the three cases or only average case. So here whether the number of times this basic operation is executing depends only on the problem size. Now let us see. So here array is unique. How many times we compared here? Total here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here for the array is unique, we executed this for 10 times. So whereas it is for not unique, so here we how many times execute? 4 or 7 and only 8. So now the number of times the basic operation executing keep changing. So that depends on how we give the input. Similarly, assume, suppose if I give the input element, like this 9 and 9, both are 9. That means suppose if the first two elements are same, so this condition A of I is equal to A of J becomes true in the very first comparison. And at that time it comes inside return false. At that time we are executing only one time. So that will be the best case. So here the number of times the basic operation executing depends not only on the problem size, but how we give the inputs. So here we need to find all the three cases, especially we need to find big O and big omega separately. That is best case and worst case. Now, when the best case occurs, so best case occurs when we give the input like when the first two elements are same. Okay, so if I give the input like this, so now the first time I selected this one, when I compare, then only this condition becomes true, it comes inside and return false. So at that time we are executing only one. So I will write C best of n. So I am taking C by why? Because comparison operation, the basic operation. So comparison operation first cut as C, I am taking that one. Okay, so C best of n belongs to big omega of 1. That means at the best case we are executing this comparison operation only one time. So now when the worst case occurs, now worst case occurs in two situations. Situation 1, when the last two elements are equal. Suppose like this, 4, 2, 2. So like that, so now at that time, I am going to get this one, the last comparison, last 10th comparison. At that time also, we need to check all the comparisons. Suppose if there is no elements are unique, so okay, at that time also we need to check all the elements. Okay, this is the situation 2. So at the worst case, now I'll write C worst of n is equal to, see in our algorithm 2 for loops are there. So I'm using 2 summations. The first for loop is running from I is equal to 0 to n minus 2. 0 to n minus 2, so I is equal to 0 to n minus 2. Second for loop running from I plus 1 to n minus 1, so j is equal to I plus 1 to n minus 1. And for each iteration, we are executing the comparison operation 1. So now apply formula for this. Okay, so for this, now it is equal to I is equal to 0 to n minus 2. So now upper limit minus lower limit plus 1. So now I got n minus 1 minus I. Here I is depending on the value. Okay, so it is varying. So now keep replacing the value of I by 0, I by 1 like that. So now let's suppose if you put I is equal to 0, what happens here? I is equal to 0, it becomes n minus 1, then summation plus. Next value of I is 1. If you put I value 1, so n minus 1 minus 1, it becomes n minus 2. Next again put I is equal to 2, so then becomes n minus 3. So like that, it keeps going. At one time it becomes 1, 0. Now this can be written as z, okay, n into n minus 1 by 2. So same thing can be written as n square minus n by 2. So n square by 2 minus n by 2. Now out of these two terms, n square is the most dominating term. So what I will write, C worst of n belongs to big O of n square. So this is the time complexity at the worst case. Okay. So now let us see here. For 5 elements, how many times? 10. 5 elements, how many times we are executing the comparison operation? 10 times. Okay. See, now you replace here n square in minus n by 2. N is equal to 5. 5 square. 5 square is 25. 25 minus 5. 20, 20 by 2, 10. Exactly we are getting. So exactly we are doing the comparison operation these many times. So this is how to analyze the any non-recursive algorithm mathematically. Hope you people understood. Thank you.